launch the maps reduces, right? If you see the MapReduce of the Hadoop, you have the job tracker, which is the central controller of the job execution or the job control. And on individual machines, I'm talking about a cluster of machines, 100, 200, right? It could be any size. So on these machines, you will have another process or daemon running called as task tracker, which will take the instructions from the job tracker to run a specific map on a specific file split, or run a reduce on a specific key and its set of values, right? So this, so here I am representing the map and reduce together. Does not mean that they will run together. These are the slots. These are the capacity of that particular node, of that particular task tracker, how much work it can do, how many tasks it can run, right? So all this framework, the job tracker, the task tracker, and all the the shuffle code that the Hadoop MapReduce framework has, is making this MapReduce program execution a possibility. Right? It's a very complex system to execute parallelly, monitor it, and then make sure that any failures are recovered. It's a highly fault-tolerant system. The Hadoop MapReduce is a very highly fault-tolerant system that even if a particular task fails, it has the ability to restart. It has the ability to recover from that specific failure without restarting the entire job. So that is the Hadoop MapReduce, the architecture. What exactly the daemons that it has and how they make it possible to execute a job on the cluster, MapReduce cluster. So here, though I have represented the HDFS as a separate, a single box, it is not a single thing. I just represented that as a system, HDFS system. HDFS system is also very similar to what we are seeing here on the MapReduce. It also has a master and slave daemons. But for the simplicity's sake, I represented HDFS as a single system, which is accessed by your jobs. It could be job tracker or the task tracker for getting the file system information. So, but will it survive the data deluge? Why this question is coming in the first place? Because the demands are changing, right? So if you see the MapReduce very closely, it is a batch-oriented system. When you run your job, it has to initiate the map tasks on each individual machines. It has to find out which machines are available. It has to monitor. It has to do the shuffling. It has to aggregate, run your reducers. So it will take, it has some lead time. It has some initiation time, setup time. And then you have so much of data that you are processing. Right? So it is mainly meant for the batch processing. It is not like your RDBMS, right? You just say select something from somewhere, it will immediately show you. It is not the real-time responsive system. It is a batch-oriented system. That's one of the limitations or shortfalls of the MapReduce system. And also, not all problems can be solved through MapReduce. Right. There are certain use cases, certain problems in the industry. Typically, the graph problems where you have to traverse the entire graph end to end. And some of the scientific problems where you need to have all the data together to process. The MapReduce is taking the advantage of the distributed system. Data is split across, scattered, and then it is going and individually handling each piece. But not all algorithms can work like this. Some of the algorithms will need all of the data together then and there to process and get the output. So some of the problems cannot be solved through the MapReduce. And we are also getting very impatient. Right? We want to get everything on our mobile. and enterprises want to know if anything has gone wrong with their systems or anything gone wrong with their products or their reputation. They want to know instantly, right? Somebody posts some tweet, a bad tweet on their product on Twitter. They want to know within 4 or 5 minutes. You know, so I'm outside. I want to get the message on my mobile, so that I can take a corrective action. These are the kind of demands that are coming today. And again, so though in the beginning I said the data volumes as one of the challenge, that is not the only challenge actually. The challenge is also about the responsiveness. The challenge is also about the structure of the data. The data that you are getting from Twitter, Facebook, or any media or website of your interest will not be structured. You can make some sensor to fit. You can attach some structure to that, but it will not be in a structure that you want, where you can comfortably load into your database or your data warehouse and process it. Each website will have its own format. Each, the person where you have the data publicly available, they will have their own structures. So that is also one challenge. You want to process all kinds of data. They are all voluminous, and you want to, some of the times you want to process them instantaneously. Immediate gratification we want. So these kind of things again cannot be addressed by the MapReduce by its batch processing nature. So what's going to happen to MapReduce? Is it going away? Is it going to disappear? My sincere answer is no. It is not going to disappear, because you want to process the distributed data and get an integrated result. You need some way to combine it at one point of time. They need to crisscross, they need to touch each other and group together with the similar kind of data in one place, so that you can say there are 10 apples, 100 oranges, so on and so forth. Otherwise you cannot. Otherwise you have to move away from the distributed file system or distributed system, which means that you are getting back to the older architectures which suffered with a lot of bottlenecks. So my belief is that the MapReduce is not going to disappear, but it is going to improve. It is going to adopt itself to turn into different forms, different shapes, right? So we already see some of them, and also when the experts or when the people talk about no, MapReduce is not going to exist, it's going to disappear. So what most of the times they mean is the Hadoop MapReduce, or maybe the Hadoop MapReduce API or the specific implementation, because there are some pitfalls in the way the Hadoop MapReduce is implemented. It processes one key at a time, right? And then it cannot store the state while processing. There are some certain things which there are workarounds, but it will be cumbersome. So I believe the Hadoop, the MapReduce implementation might change, or some alternates or some variations of that MapReduce will be adopted, will be created by different products or different tools that are coming on top of the Hadoop, which will still will use MapReduce, I believe. So we'll see that shortly. Right. So what are the alternates to the Hadoop, the MapReduce? So one of the alternate, I don't call it as alternate, the yarn. Yarn is actually, it tries to improve the MapReduce. It tries to improvise the MapReduce. At the same time, it will allow other kinds of applications other than the MapReduce to function. So what is a MapReduce application? MapReduce application consists of a MapReduce along with the shuffle phase introduced by the MapReduce engine, and then it will give out the analytics that you are desiring. So that is a MapReduce application. It is not an integral part of the Hadoop or any other system. So the pitfalls or the shortfalls of the MapReduce are covered by Yarn, and Yarn actually grown as a separate the application which can host a MapReduce application and various other applications as well. So Yarn, what is Yarn? It is yet another resource negotiator, and also some of the people say that it is also Yahoo resource negotiator because it's basically took birth in Yahoo's team. But it's popularly called as yet another resource negotiator. So which actually relieves the MapReduce of the responsibilities of launching the job, scheduling the job. So all these kind of things, generic resource management. It will relieve the MapReduce from all these things and just let it do its job execution and job monitoring, these kind of things. But whereas the cluster resources such as allocating the resources on each of the machine, so these kind of things are handled by the Yarn framework. So now the MapReduce becomes a simple application that runs on top of Yarn, and this MapReduce is actually called as MapReduce 2. The previous one is named as MapReduce 1, and the MapReduce that runs on Yarn is the MapReduce 2. So what this gives, Yarn gives, is enormous scalability, because it is not monitoring the individual jobs anymore. It is just taking care of the clusters resources such as the machines, the RAM, and then the availability of these machines. All these kind of things are taken care by Yarn, whereas the individual jobs, individual applications such as MapReduce and some other applications that have taken birth on Yarn or that have been migrated to Yarn later on, which we will shortly see. So those applications individually will take care of their applications, recovering from failures, and then monitoring and then collecting statistics from their job when it is running. So all these kind of things are done by the individual applications like MapReduce, or it could be applications like Impala, it could be HBase, any other application that can run on Yarn. So the Yarn not only improved the MapReduce one, but it also has given the possibility, opened up for so many other applications which can run on Hadoop today. But the question is, why those applications should run on Hadoop? The reason is the Hadoop is not only a processing engine, but it is also a data store. It has all the data that you want to process, your big data, on its HDFS platform. If you want to process the data, earlier it used to be the only MapReduce way of processing, but now you can process this data in several other ways, right? So what are the other ways of processing data on Yarn, or processing the data on which is residing on HDFS? So